Hello, this is Keith Capellaro from K-Dawg Weather. Today I'm going to be doing a PowerPoint presentation of exploring the troposphere, structure, dynamic, and significance. Okay, the agenda overview is defining the troposphere, composition and properties of the troposphere, weather phenomenon and process, human impact, and environmental concerns. Defining the troposphere. Position within the Earth's atmosphere. The troposphere overview. The troposphere is the Earth's lowest atmospheric layer, extending 8 to 15 kilometers and containing most atmospheric mass. Location relative to the stratosphere. The troposphere lies below the stratosphere and plays a vital role in weather and climate. Variability and thickness. Troposphere thickness varies by latitude, thicker at the equator and thinner at the poles due to temperature and circulation. Physical characteristics and boundaries. Temperature decrease with altitude. The troposphere experiences a temperature drop about 6.5 degrees Celsius per kilometer as altitude increases. Tropopause boundary layer. The tropopause serves as a temperature inversion layer separating the troposphere from the stable stratosphere above. Altitude variation of the tropopause. Tropopause altitude varies from 8 kilometers near the poles or 18 kilometers near the equator due to seasonal and latitude factors. Vertical mixing in weather. Strong vertical mixing in the troposphere facilitates weather phenomenon and dynamic atmospheric changes. Composition and properties of the troposphere. Chemical makeup, gases, and particulates. Primary atmospheric gases. Nitrogen and oxygen dominate the troposphere, making up nearly 99% of its compositions. Trace gas impact. Trace gases like carbon dioxide, methane, and water vapors play vital roles in climate and atmospheric chemistry. Suspended particles. Particulates such as dust, pollen, soot, and aerosols influence air quality and cloud formations. Pollution and atmospheric change. Natural and human pollutants alter troposphere composition, affecting air quality regionally and locally. Temperature and pressure variations. Temperature gradient. Temperature decreases from around 15 degrees Celsius at the surface to minus 55 degrees Celsius near the tropopause in the troposphere. Atmospheric pressure decreases exponentially from 1013 HPa at sea level to about 200 HPa near the tropopause. Weather system development. Temperatures and pressure gradients drive vertical air movement, essential for weather formation and dynamics. Seasonal and latitude effect. Seasonal and latitude changes further influence temperature and pressure variations in the troposphere. Altitude-dependent changes. Air density and temperature. Air density and temperature decreases as altitude increases within the troposphere, impacting atmospheric conditions. Ultraviolet radiation exposure. Ultraviolet radiation exposure rises altitude due to thinning atmospheric shielding, affecting chemical interactions. Cloud formation and chemistry. Altitude changes influence cloud formation and gas phase chemistry, though physical and chemical interaction. Atmospheric stability and weather. Variation in stability and moisture with altitude affect convection and turbulence, crucial for weather phenomena. Weather phenomena and process. Formation of clouds and precipitation. Cloud formation, right up here. Cloud formation process. Cloud formation as moisture rises and water vapor condenses on condensation nuclei in the troposphere. The types of clouds. Cumulus, stratus, and cirrus clouds indicate different moisture levels and atmospheric stability conditions. Precipitation foundation. Precipitation occurs when droplets or ice crystals grow large enough to fall through the atmosphere to the ground, as you can see right here. You can see the water. You can see the precipitation falling to the ground. Roles in weather systems. Troposphere and weather. The troposphere contains most of Earth's weather due to heat exchange, moisture, and vertical air motions. Key phenomena. Cyclones, anticyclones, fronts, and jet streams are major weather phenomena in the troposphere. Temperature and convection. Horizontal temperature, contrast, and vertical convection drive large-scale weather patterns and events. Constant mixing and energy exchange in the troposphere influences local weather and global circulation. Influence on climate patterns. Troposphere role. The troposphere mediates heat and moisture exchange vital for regulating Earth's climate system. Greenhouse gas reservoir. This atmospheric layer stores greenhouse gases, influencing radiating force and global temperature trends. Climate phenomenon impact. Tropospheric variations affect significant climate phenomena like El Nino, monsoons, and jet stream shifts. Importance for climate models. Understanding troposphere variability is essential for accurate climate modeling and prediction efforts. Human impact and environmental concerns. Air pollution and its effect on the troposphere. Sources of tropospheric pollutants. Human activities releases nitrogen oxides, sulfur dioxide, carbon monoxide, and particulate matter in the troposphere. Smog and acid rain formation. Pollutants alter photochemical reaction, causing smog formation and acid rain, harming ecosystems and human health. Tropospheric ozone impact. Tropospheric ozone acts as a greenhouse gas and respiratory irritant, contributing to climate change and health issues. Importance of monitoring. Monitoring and mitigating pollution in the troposphere is crucial for protecting environmental and public health. Global warming and greenhouse gases. Roles of the troposphere. The troposphere traps infrared radiation through greenhouse gases, driving the greenhouse effects and warming. Impacts of human emissions. Industrial activities have increased greenhouse gases levels, causing temperature rises and climate shifts. Tropospheric warming leads to extreme weather conditions and rising sea levels globally, which has the consequences and warning. Mitigation strategies. Efforts focus on reducing emissions and increasing carbon sinks to combat global warming. Scientific research and monitoring. Troposphere observation methods. Satellite remote sensing, weather balloons, aircraft, and ground stations continuously monitor atmospheric temperatures and composition. Advance in atmospheric modeling. Improved atmospheric modeling enhances understanding of tropospheric processes and their global environment impacts. International data sharing. Global network facilitate data sharing and pollutant tracking, supporting climate policies and accurate forecasting. Troposphere stratosphere research. Research explores interaction between troposphere and stratosphere and studies emergent atmospheric phenomenon. Conclusion. Understanding the troposphere's vital roles in our atmosphere. Troposphere structure. The troposphere is the lowest atmospheric layer with distant temperatures and pressure gradients essential for weather and climate influences. Dynamic weather process in the troposphere critically affects climate system and human life globally. Impacts of pollutant and global warming. Pollutant and climate change in the troposphere significant risks, highlighting the need for environmental protection. environmental stewardship. Ongoing research and stewardship efforts are vital to preserve the troposphere balance and health. Thank you very much. This is Keith Capellaro from K-Dawg Weather. Please like and subscribe to this channel. Thank you.